In this session, we'll solve one more problem on Hilbert transform. Find Hilbert transform of triangular function which is defined by this equation. So let us plot the signal in step 1. So write time axis and locate the coordinates on time axis. For t is equal to 0 to 1, we have 1 minus t, that is decreasing ramp, and then we have for 0 to minus 1, we have t plus 1, that is nothing but increasing ramp. So x of t here is nothing but triangular function. In step 2, we are going to use time domain analysis procedure in order to find Hilbert transform of this triangular signal. So from our previous discussion, Hilbert transform of x of t is given by convolution of two signals, that is x of t and h of t. So this can be written in convolution integral form as shown. So what is x of tau here? It is nothing but triangular function. Replace x of tau by triangular function and apply the limits minus 1 to 1. When you plot this signal here, one can see minus 1 to 1 the signal exists. Therefore the limits of integration you have to put minus 1 to 1. Triangular of tau 1 by pi into t minus tau d tau. Now separate this integration level. Minus 1 to 0, I have here tau plus 1, and 0 to 1 I have 1 minus tau. Therefore now after writing this integration, we have to now add and subtract t in numerator in order to get the answer. Therefore x cap of tau, that is Hilbert transform of x of t, is given by minus 1 to 0 integration tau plus 1 I am adding 1 t and I am subtracting 1 t. So the effect will be 0 here. Here also in the second part of this expression, I have added 1 t and minus t here, because in the denominator I have t minus tau, here t minus tau. Therefore by adding and subtracting t won't affect the expression. Now rearrange the terms. When you rearrange the terms, you are going to get the expression like this: integral minus 1 to 0 minus t minus tau plus 1 plus t by pi into t minus tau d tau. Since in the denominator I have t minus tau, let me group t minus tau here. Here also let me group t minus tau in numerator as we have in denominator. So on separating the terms, so I am going to get here the expression as shown here. So here t minus tau get cancelled. We are going to get integral minus 1 to 0 minus 1 by pi d tau, plus here we can write the integration minus 1 to 0 1 plus t by pi into t minus tau d tau, plus here t minus tau get cancelled. Therefore you are going to write integral 0 to 1 by pi d tau, plus you write this expression as it is because there is no term cancels here. Now let us come to the next important part. Here in the denominator we are able to see t minus tau. Therefore we are going to use substitution method here. So let t minus tau is a. Therefore on differentiating we are going to get minus d tau is equal to dA. What is d tau? D tau is minus dA. So apply the integration level. Because of the substitution method it changes. So when tau is equal to minus 1, here a becomes t plus 1. When tau is equal to 0, a is equal to t. When tau is equal to 1, a is equal to t minus 1. So rewrite the expression. Hilbert transform of x of t is given by integral t plus 1 to t plus 1 by pi a minus dA plus integral t to t plus 1, 1 minus t by pi a minus dA. Now, what is integral of 1 by a dA? It is ln of a. So, rewrite this expression and apply the limits and simplify. So, we are now able to get this expression. Now, group the terms here. So, I have here minus 1 plus t by pi ln a t to t plus 1 minus of 1 minus t by pi ln of a with the integration limits t minus 1 to t. Apply the integration limits. Since 1 by pi is common, let us take minus 1 by pi common. So, minus 1 by pi of, here I have 1 plus t. On applying the integration limits, it is ln of t minus ln of t plus 1. Plus, here I have ln of 1 minus t into ln of t minus 1 minus of ln of t. So, now let us simplify this by rewriting the terms, each terms here. Multiply ln of t minus ln of t plus 1 by 1 plus t, multiply ln of t minus 1 minus ln t by 1 minus t. Check whether any term cancels or not. On expanding this, we are going to see here ln of t and minus ln of t is here, therefore it cancels each other. Now group the similar terms here. That is nothing but minus 1 by pi into, here I have ln of t minus 1, here ln of t plus 1, and here I have t ln t, and here I have t ln t, and here I have ln of t plus 1 and ln of t minus 1. So, group each terms. So, we can write like this: minus 1 by pi into ln of t minus 1 minus ln of t plus 1. Add these two terms, it is t ln of t plus t ln of t is 2t ln of t. And here you are able to see minus t ln of t plus 1 minus t ln of t minus 1. Rewrite and you simplify further, that is minus 1 by pi. This is in the form of ln a minus ln b, it is nothing but ln of a by b, plus here t is common in 3 expression, take t as common factor. Since you have 2 ln t, it can be written like ln of t square minus of, here I have here minus of ln t minus 1 plus ln t plus 1. So, what is this form? It is ln of AB form. So, it is written like this. Now, rewriting the expression, minus 1 by pi ln of t minus 1 by t plus 1 plus t into, here this is in the form of ln a minus ln b, that is nothing but ln of a by b. So, t into ln of t square by t square minus 1. So, finally, let us remove this negative sign. So, 1 by pi into ln of denominator will go to numerator and numerator will come back to denominator when you multiply it with negative sign. So, this is the answer, plus t ln of t square minus 1 by t square.